Okay, so now pretend I know two vectors, right? And a point A. So the point A is A1, A2, A3 on the plane like this. And the point, these are not the point, these are the point C1, C2, C3. They have 3 points. You can write equation for the plane. But what does it mean? The vector here, so remember two vector here, right? If I have any vector, I pick any point right here. So I pick any point, I put from 0 here, right? So this one here, the vector here we call the vector R, represent the equation of the plane. The point can jump all over the plane, right? The vector go around, touch the plane. So the vector R here is the how to get the vector R. You have if you know this vector here is, let's say this is point P here, X, Y, Z here. If you take vector here, you add with vector A and you get vector R. Can you see that? So vector R here equal vector A. So the point A can be represented by the vector from here to here, right? So equal vector A, which is A1, A2, A3. Okay, you add with. So add with what? So add with AP. Okay, the vector AP. So now how to find the vector AP? So I already represent, you have any two vector here. Any point here can be represented by the combination between two vectors, right? So let's say vector VC. So remember vector here is not C1, C2, C3. This vector here, let me go this on vector C, but this one is C minus A. So this vector here attach C1 minus A1. So to get the X here and Y here equal C2 minus A2 and C3 minus A3. That is vector AC. Okay, the vector AC. So vector AB equal the combination of AC and AB. So that means AP equal lambda, the lambda AC, okay, plus the beta AB. Okay, so that gives you AP. Then you add with A1, A2, A3 original vector, which is the point given right here, and they give you 3 points. You can find the vector here. So what AC vector equal? AC equals C1 minus A1. You have minus, you move this one into here, then you have the vector C, okay, AC. So alpha times C1 minus A1, C2 minus A2, and C3 minus A3, okay, lambda. And you add A1, A2, A3, you add with that, and then you add with beta. So AB equal B1 minus A1, B2 minus A2, and B3 minus A3. So that is R. Okay, then R equal what? R equal X, Y, Z, where any point on here will be governed by this vector here. Okay, the combination of. So now I repeat again the last time. So I have the vector C. Vector C means from here to here actually, but I want to turn vector C into here. Okay, let's say this one vector C1. Maybe these are not really good because vector C is supposed to be from here to point C. But let me make something, like, okay, so I make up something like, how about P? No, P represented by, okay, how about D and E? Okay, D and E. Okay, the point E. The C is D minus A to get the vector C. Okay, so okay, so now I repeat again. You have two vectors. Okay, two vectors like this. If you the multiplication, the sum of two vectors, right? Combination of two vectors, you get any point P right here. You can write as the vector AP. The vector AP here is the combination between vector C and vector B. Okay, you multiply C by a little bit, and you add it multiply by B a little bit, and you add of them. They're going to have any point on the plane here. So the plane will be like this, or any point P here, y, z. Didn't fit, right? We know this vector, right? But the point P can be anywhere. So the point, if didn't O, so OP equal R. Okay, OP here is the equation of the plane, vector equation. So OP like this. P can be here, OP, OA, okay? So OP have to be equal OA. Add with AP. P can be anywhere. Didn't fit, okay? So OA plus OP. And OA here, didn't equal R, okay? So didn't equal R, so OA equal A1, A2, A3. You add with, so OP equal vector C here. Vector C here is the combination of linear combination, some number time P lambda and beta time B. So you add up, you get that one, okay? So if OP here, OP equal combination of vector C here plus beta B, okay, beta time B. So equal OP. So what is C equal? C equal the point D minus point A. Okay, so let me change again. So I don't like this, but at least you know this one C1, C2, C3. Okay, vector big C. Okay, then this one A1, A2, A3. So vector here is the point B here B1, B2, B3. But vector B here is not B1, B2, B3. B3 here is B1 minus A1. You see that? So here is alpha. So you have a lambda C here, vector C here equals C1 minus A1. Okay, C1 minus A1 and C2 minus A2 and C3 minus A3. Then you add with beta B1 minus A1, B2 minus A2 and B3 minus A3. So this gives you a vector equation of the plane. So now the same thing with two dimension, right? This one, the first form, we have three form. Okay, so three form. So the first form here we call the vector form, right? R is a vector. So second form is you can turn on to the point. So you get X, Y, Z equal A1 equal this, right? So therefore I change that this X equal this. X equal A1 plus alpha lambda C1 minus A1 plus beta B2 minus B1 minus A1. So Y equal A2 plus lambda C2 minus A2 plus beta B2 minus C2. Finally, you have Z equal A3, the point, plus lambda C3 minus A3 plus beta B3 minus A3. Okay, so this one we call the parametric form of the plane. The third one would be what? What is Cartesian form, right? Cartesian means your equation relate between x1, z, and this one have to be gone. Okay, alpha, beta have to be gone. So how to get rid of them? So we can use we can use substitution method to solve for b and alpha, right? So the next one I will give you the point, okay, the point number, and you can understand the third one better. Okay, we can manipulate this one here, but it causes a lot of. Okay, so now the problem can be confusing for the beginner. So I try to distinguish the notation. Okay, they ask you to give you a point A, also the vector A, and the vector B and vector C. Okay, you use three of them, the point and two vector, to write equation for the plane, right? So now actually A, for example, I can put 1 or 2 here on the plane, this plane here, and the vector like this. B here is not the vector from here to B and from here to C. Actually it should be, but B here is right there. Okay, B here 2, 1, 1. This one here always the position vector. So if you want to find, for example, the point C here is not 3, 0, negative 1. So if you want to see if C here equal 3, 0, negative 1, you have to put C here have to be 4, because 4 minus 1 equals 3, right? And this one, whatever, 2 here, minus 1 equals 0, right? And this one, minus 1, that means minus 1 here, okay? So then let me give you example with already they give. So I bring this vector up there, okay? Okay, so this vector here is vector C here equal this, okay? So this vector here equal this point here minus A equal this, and this one minus this equal that, okay? So equation very simple. You have R equal 1, 2, 0. You add with lambda 2, 1, 1, and you add with beta 3, 0, minus 1. So that is the equation of the plane, okay, in vector form. So now you want to change into now I repeat again. So the point C here, or the other vector big C here, have to be the point C1 here, subtract 1 have to be equal 3, okay? So therefore this one here have to be 4, this one have to be 2, because 2 minus 2 equals 0, this one have to be minus 1, minus 1, minus 0 equal minus 1, and this point here have to be, the point here have to be 2 mean 3, 3 minus 1 equal 2, and this one 2 here have to be 3, 3 minus 2 equal 1, and finally 1 minus 0 equal 1. So that is the point, but the vector B here, this one subtract this one, okay? So after I subtract, I get the vector here, and I put in there, okay? So finally, this on the first form of the plane, given the point A and 2 vector B, or if they don't give you 2 vector here, you have to give you the point. Okay, imagine you don't know that vector, right? So if they give you a point here, you want to find vector C here, you take 4 minus 1 equal 3, that is this one. 2 minus 2 equals 0, what is this one? And minus 1 times 0 is minus 1. If on to find vector here, you have to take this, the head, subtract the tail. 3 minus 1 equals 2, and 3 minus 2 equals 1, and finally 1 minus 0 equals 1. So that is the vector. Now we can change into Cartesian. So because since R equal H, Y, Z, right? So R here is the vector from here to any point P here, which is H, Y, Z. P can jump all over the place, okay? So therefore H equal 1 plus lambda, 2 lambda. Now I change a little bit, 2 lambda plus 3 beta, okay? And Y equal 2 plus lambda, 1 lambda plus 0 beta, and Z equal 0 plus lambda minus 1 beta. So this one we call the parametric form of the plane. Finally, when you turn this one into the Cartesian form, you have to write it up A and B, right? So then you have to use linear combination to solve for alpha and beta in terms of X and Y, okay? I leave this for you, because this one just label work, it's nothing, okay? So finally, then you turn into the form, include only X, Y, Z and some number. Okay, let me see how it works for the number over there. Okay, so how it's work here. So here how it's work here. So another way is you can write vector AP. Okay, you add it OA, you still have the vector R, right? So you add vector A, OA, okay, add with AP. It's supposed you get OA, add with AP have to be add AP have to be vector R, which is represented by the vector, the plane, right? Vector form of the plane. So now how to find AP? I take P minus A. Okay, I take P minus A, which is A equal this. So I have OA, the vector OA equal 1, 2, 0, and I add with AP is h minus 1. That is for this vector here, and y minus 2 and z minus 0. So this combined also equal to vector r, the same thing, right? So this one here is another form using the point x and y. Okay, so now this one turned out to be the other form. So you add vector OA, you add vector OP, and you get vector OP. So that is the vector form as well. Okay. Okay. So the next one is how to find the equation between this. Okay. So equation between this, in this case, you can, as I'm saying, you can eliminate alpha and beta. You get rid of alpha and beta. Then you have equation between only h1z, right? So we call the Cartesian. But another way is I introduce in the next vector is you just simply you use you apply with the cross product, you find a normal vector here, right? You cross B and C, you cross them, you get a normal vector. So if after you found normal vector here, you dot with vector P here, you will have 0. That is give you equation of a plane. So next I do both method, right? I use the same example here. We continue to do the other way. Okay, I find the normal vector here, and I dot with vector PA here, then equals 0. That gives you the same result with if you eliminate alpha.